Hey Shri, this is my video project assignment and this is Ujjal Bath. So in this assignment, we were asked to analyze a structure of our choice and we were asked to determine the loads on the beam part of the structure and we were asked to calculate the support reaction forces, the shear forces, the bending moments, as well as the deflection and the angle that were caused by the load placed on the beam. Moreover, we were also asked to present a detailed calculations of max tensile or compressive bending stresses and maximum shear stresses and principal stresses and in-plane shear stress and the failure planes. So the structure that I chose was a bridge located near my home at near Rippleside Terrace at Tarneet. This is me here standing on the bridge, which has the length of 16.15 meters, height of 1.15 meters, and the length of the deck being 2.25 meters. So the reason why I choose the bridge, which is primarily made from wood, is because I was curious that how was it able to support people and how was it able to withstand failure. So we were given a uniformly distributed load of 16.65 kilonewtons per meter. So I resolved that into a point force, or we can say a point load of 134.45 kilonewtons. I used that value to calculate the support reaction forces using the equilibrium equations, with AY being 44.79 kilonewtons and BY being 89.66 kilonewtons. Afterwards, we were asked to calculate the shear force diagrams and the bending moment diagram. I for that I used an arbitrary x value to calculate the V and M functions. That came out to be V equals 44.79 minus 333 over 644 times x square, and the M equation being this one. Um, and to and then I calculated the shear force at the important points, which is the starting point, the ending point, and also calculated the distance where the shear force was zero. Similarly, I also calculated the bending moments at the same important points, which came out to be 0 and 0 at the starting and ending point. Um, and I also calculated the bending moment max, which was calculated using the same value where the shear force is 0 and the distance that was 9.32 meters, and substituting 9.32 into the bending moment equations gives us 278.34 kilonewton meters. And here is the shear force diagram, and here is the bending moment diagram giving the M max. Then we were asked to calculate the deflection and the slope equations. So in order to calculate that, I used EI d square V over dx square equals M. And to get the slope, I used the equation EI theta equals the integral of the moment equation. And for the deflection, I used the EIV equals the double integral of the moment equation. Then I used the boundary conditions to solve for the constants, and that gave me the slope and the deflection equations. And then I first calculated the moment of inertia using the cross section dimensions of the beam, and then I used that value to calculate the max deflection and this max slope. The maximum deflection occurred where the slope is 0, and that came out at a distance of 8.38511 meters. And then I substituted the value into the deflection equation to give me a deflection of 44.8284 millimeters. And then I used the then I calculated the slopes at the starting and the ending points. Afterwards, we were asked to calculate the maximum bending stresses and the maximum shear stresses. And the maximum bending stress was 9.467 MPa, and the maximum shear stress was negative 0.427 MPa. And then I also calculated the principal stresses where the sigma x was 9.467 MPa, sigma y was 0, and tau xy was also 0, and which came out to be 0 and 9.467 MPa. And the failure planes where it occurred was at 0 degrees and 90 degrees. And the maximum in plane stresses were also calculated where sigma x equals 9.467 MPa, tau xy was negative 0.427 MPa, and sigma y were 0. And that came out to be 4.753 MPa. And the failure plane that shear stress occurred was at 42.42 degrees and negative 47.58 degrees. And that is given by this elemental diagram. So the allowable shear and bending stress for the material of the bridge, which is wood, given were 4 MPa for sigma, which is denoted by sigma allowable, and 2.5 MPa, which is denoted by tau allowable. So in conclusion, we can say that the structure will fail at 0 degrees and 90 degrees if it is governed by tensile stress. Or we can also say that the structure will fail at 42.42 degrees if it is governed by shear stress. So to recap or to conclude, I would say that it was observed that the maximum shear force carried by the bridge was 89.66 kilonewton and the bending moment was 278.34. And both these values were used to calculate the maximum deflections, the maximum slopes, the maximum tensile and shear stresses. So it can be interpreted from the calculations that the selective structure would fail at the maximum bending stress of 9.467 MPa at 90 degrees as the allowable tensile stress is only 4 MPa. Or we can also say that it will fail at maximum shear stress at 4.753 MPa at 42.42 degrees as the allowable shear stress for wood is 2.52 is between 2.5 to 3 MPa. So in to reflect, I would say that this assignment was a difficult yet an enjoyable task. The most challenging part of this assignment would be for me would be understanding the failure planes, the principal stresses, and the maximum inflation stress. But I overcame this problem by reading back on your theory, the examples, and your tutorial notes. I also emailed you whenever I was in doubt, which helped me tremendously. I believe this assignment played an integral part in making the structural analysis subject more valuable as it made the students utilize the theory that was learned in class to a more practical situation. Thank you very much for listening and watching.